HZ ions. HZ ions are the high-energy nuclei component of galactic cosmic rays GCR, which have an electric charge greater than +2. The abbreviation HZ comes from high H atomic number Z and energy E. HZ ions include the nuclei of all elements heavier than hydrogen, which has a +1 charge, and helium, which has a +2 charge. Each HZ ion consists of a nucleus with no orbiting electrons, meaning that the charge on the ion is the same as the atomic number of the nucleus. HZ ions are rare compared to protons, for example, composing only 1% of GCR versus 85% for protons. HZ ions, like other GCR, travel near the speed of light. Their source is likely to be supernova explosions. In addition to the HZ ions from cosmic sources, HZ ions are produced by the Sun. During solar flares and other solar storms, HZ ions are sometimes produced in small amounts along with the more typical protons, but their energy level is substantially smaller than HZ ions from cosmic rays. Space radiation is composed mostly of high-energy protons, helium nuclei, and high-energy ions, HZ ions. The ionization patterns in molecules, cells, tissues, and the resulting biological harm are distinct from high-energy photon radiation, X-rays, and gamma rays, which produce low linear energy transfer, low ELT radiation from secondary electrons. While in space, astronauts are exposed to protons, helium nuclei, and HZ ions, as well as secondary radiation from nuclear reactions from spacecraft parts or tissue. Prominent HZ ions: carbon C, C, oxygen O, Gen O, magnesium Mg, silicon C, iron Fe. GCR typically originate from outside the solar system and within the Milky Way galaxy, but those from outside of the Milky Way consist mostly of highly energetic protons with a small component of HZ ions. GCR energy spectra peaks, with median energy peaks up to 1000 MeV/Amu, and nuclei with energies up to 10,000 MeV/Amu are important contributors to the dose equivalent. Health concerns of HZ ions. Although HZ ions make up a small proportion of cosmic rays, their high charge and high energies cause them to contribute significantly to the overall biological impact of cosmic rays, making them as significant as protons in regard to biological impact. The most dangerous GCR are heavy ionized nuclei such as Fe+26, an iron nucleus with a charge of +26. Such heavy particles are much more energetic, millions of MeV, than typical protons accelerated by solar flares tens to hundreds of MeV. HZ ions can therefore penetrate through thick layers of shielding and body tissue, breaking the strands of DNA molecules, damaging genes and killing cells. For HZ ions that originate from solar particle events (SP), there is only a small contribution toward a person's absorbed dose of radiation. During a SP, there is such a small amount of heavy ions generated that their effects are limited. Their energies per atomic mass unit are all significantly less than protons found in the same SP, meaning that protons are by far the largest contribution to astronaut body exposure during SPE.